So welcome back. What if you have a class called A, and inside your class you're having an abstract method called show. We can create another one called can be of type config. I don't want them to return anything. Type config, something like this. So automatically after making abstract methods, automatically the class that they are defined in, it has to also be an abstract class. So what if you have such a class in your program? So while designing, we have what we call hierarchies that we follow. In the coming videos, we shall be looking at what hierarchy mean, but today we are going to focus on something interesting. So there is an alternative for doing abstract. Here we can use something called interface. An interface. Sorry, an interface. Interface. An interface. We can use something called an interface. So simply, what is an interface? An interface is like a blueprint for a class. It defines what a class should do, but not what it defines what a class should do, but not how the class should do it. So this interface simply means it is just simply, let me give you an example. You're asking me the direction. I'll tell you, you go right and left. I'll just tell you I won't implement, meaning I'll give you the design pattern, but I won't design the actual thing. Meaning an interface is not a class. Yeah, an interface is not a class. When I come down here, I can create an instance for that, interface, I can say. So I can come down here. I can say A, which is our interface, is equal to object. So I can create this instance here. This is not an instance, sorry. This is like a reference. This is like a type. The way you see that we do types for classes, let me say you're having a class here, class A. You can do a type and you reference it. That's the same thing as I have done here. But to prove you that A is not a class, let me try to create a new instance of this interface. I will say A here. Now I can leave that one. I can say A object 2 is equal to, I try to create a new instance of A. A new instance of A. You see that this is not accepted. I can also compile, and you see, compile. You see that we are also getting compile errors, whereby A is abstract, cannot be initialized under this. And the other thing I forgot to tell you is that by default, after putting interface, your methods automatically become abstract methods. So I can remove this keyword here. Can also remove this keyword. I repeat again, after using the interface keyword, your methods inside, they become abstract. The same thing with variables. In the coming minutes, we're going to see how an interface can affect variables. So you can see that this is not a class. I have proved it here. And clear this. So now what if I want to access these two methods? Meaning I have to create the actual class. Let me say class B. In this case, being that this is not a class, we are not going to use the word extends. Yeah, that if I do this, you see that this is not going to work. Cannot be a superclass of B. A superclass must be class, meaning this automatically is not working on interfaces. So we use a keyword called implements class B, something. So after using the word implements, automatically these two methods, you have to implement them inside the class that you have created. It becomes compulsory for you to implement the two methods. Before putting that, it was okay. But after using the implements keyword and implementing our interface being our blueprint, automatically these two methods, they have to be implemented inside our class, meaning they are required. Meaning I'll come here, I'll say public. Actually, when you hover on this class, you can see they give you a quick fix. You can fix this and add unimplemented methods. No, but I don't want to do that. Let me define them. I'll say public void show. Inside here, I'll print out this is in a show. The same thing I'll do for the config. The config. So automatically after doing that, you see that everything is okay. Meaning here, I can come down here. Instead of creating an instance of A, now I can create an instance of B so that I can access the types. So when I come here and say object2 dot config, you can see that you can now access the config. Then object2 again, I want to access the show. You can see that we are able to access the show. So when I compile, hopefully you are not going to get compile errors. Compile and run, you will see that we are able to access our two methods that we defined. So that's simply how interfaces affect, or how you can deal with interfaces. To repeat again, an interface tells you how you should do, sorry, an interface only it defines what a class should do, but not how it should do it. So simply, an interface is like a design pattern, not the actual thing, but the design pattern of the thing you are trying to design. So in this case, we had two, let me say our two designs, in this case, which are our methods, the show and the config. Our interface only helped us to tell us that class A is having this design. So it was for our, it was us, the job was left for us to implement the two methods app. So let us see how interfaces affect variables. So I'll come here. Can I initialize variables? Here, I'll say int. Let me say count. I'll use count. And inside here, I will say int. I'll use like a string is name, something like this. So you can see that here I can do a comment. So what does this mean? How interfaces affect variables. So interfaces affect variables in a way that automatically after putting or declaring your variables inside your interfaces, they become they become final and static. So they become final and static. Your variables are made final and static, meaning in this case you cannot they cannot be blank. They cannot be blank. They have to have what we call default values. So in this case, my count can be 20, and my name can be let me call it something like this. So after putting this, I can remove this here. This was a reference how your interface affects your variables inside. So automatically after using the interface and you declare variables inside, they add what we call the final keyword and the static keyword. Meaning the final keyword is that you cannot modify these values, and the static keyword means that now it is part of the class. Sorry, it is part of this interface uh, interface A that we have created. So how do I access these variables? Someone can come down here and say, being that now A, these two variables are static, I can now access them through the interface. So I can say A, which is I already declared here a variable. I will say object dot. I can now access A, but is it possible? On A, can I access the count? Count? Can I access the count? Something like this. Let me just do like this. I can just print it out instead of creating a variable. So can I access the A dot name? You can see that I'm able to access A, the name inside. So when I compile this and run, you see that I'm able to access Colin inside here. Now Colin is part of this interface called A. But can I try to modify Colin? Yeah, let me try to do that. I'll say A dot name. Can I try to modify this? So let me say John. You see that we cannot modify, being that this interface just tells you the design, how you are going to implement. It tells you how you should owe the design pattern, not the actual thing. Meaning we cannot convert. Sorry, we can do this. This, yeah, meaning you cannot modify the design. You cannot modify this. And the other thing, the our something to note is that I use the word final. So something which is final, you cannot modify it. Yeah, here I was trying to reassign a name in this case, but remember we have the word final. We cannot modify static. We cannot modify variables with the word final. So that's the effect interfaces do on variables and our methods. So in the coming video, we are going to look at more of interfaces and why we need interfaces, among others. Thank you.